Good morning, my name is Daniel Lockerbie. I'm at Hoppin Hoppin. I'm an AC drive specialist. I've been doing drives for a few years. Been working with Hoppin Hoppin over 5, but actually I was contracted with them for about 8 or so years before that. So we're gonna talk about the new ACH 580 drive. You guys got a lot of ABBs in the building. You're used to the 550s. This is the next generation 580. A lot of similarities, a few minor differences, but we're going to go through the layout of the drive and how it all works. This is the drive keypad. These drives have bypass modules on them. If you're familiar with the bypass on the 550s, functions exactly the same as the 550. It's the exact same. It's got some different internals in it, got more memory and bigger power supply, but it functions technically the same way. On the drive keypad here, of course, we got handoff and auto. Tells you where you're getting your control from. Auto, top left-hand corner is a graphical display where you're actually pointing at. If I put it in hand or off, that will change and follow whatever I'm doing. Top right-hand corner, that is the commanded speed. Right now you're in auto and then minimum hertz is 18. So your commanded speed, you go start this up, it's going to run 18 hertz minimum. Of course, in the middle, name of the drive, this is ACH 580. Top line display is your output frequency. Tells you how fast the drive is going. This says it's commanded at 18, but it's only going 0. If I were to hit hand, it would go up to 18 and hold. If I put it, well, it's in auto. If you get the speed signal, it'll go to 18 and then follow your analog signal coming in. Motor current, critical thing to keep an eye on. Make sure you're not overloading the motor and the drive. Let you know idea of the health of your system. And then your analog actual value, that's your 0 to 10 volt signal coming from your building automation system. And it's scaled 0 to 100%, 0 to 60 hertz. So 5 volts should be how many hertz?
30.
All right. And if I put 2 volts out, how many am I going to get? It's not going to go below 18. Correct. All right. In the menu list, a new thing in the 580, we've got a group called primary settings. If you're familiar with the old 550, you had to go to parameters, you had to go to motor data, then you had to go all the way around. ABB put 90% of everything you need, 90% of all job applications can be started and run right through primary settings. And you got a quick setup, you got some assistance. I don't usually use them, but your motor data. Nominal values, that is what is on the motor nameplate. Can't preach that enough. Don't give me, I used to have guys, especially on 200 volt, 230 volt, he'd measure 230, but the motor's a 200, he put 230 in. No, you got to put what's on the motor nameplate. These are 460, I believe. Check that out. Well, we can look. We can go into nominal values, and 9.5 amps, 460 volt, 1770 RPM. Let's see. 60 hertz, and it's a 7.5 horsepower motor. If you were to have to change this motor out, this is where you'd have to go to make this drive match that motor. Now, when you do your first startup, the drive will do an ID tune, and it'll tune the drive to that motor. So that's why it's kind of critical to make sure if you do a motor change, you go back in here and make sure your data is correct. You may get more efficient motor, you may get one a little less efficient. Out of the box, it'll run the motor, but it just won't be as efficient as if you put the actual data in there. And then other stuff. Ramps, we got 30-second default ramp start, ramp up and ramp down, and minimum 18 hertz. Your drive is also going over 60 hertz. It's going to 70 hertz for some reason. Building automation set that up to go to 70 hertz. Don't know exactly why. It may be design efficiency of the fan or the hood or whatever. I'm seeing a lot more of that in air handlers and exhaust fans these days. It's not uncommon to see over 60 hertz. I've got some running 90 and 100 hertz. So just don't be alarmed when you see something like that, but just kind of back up and say, okay, why are we doing it? These are all exhaust fans, so redundancy really doesn't apply here. But and then you're set up on a building automation system, but in the drive you can't change it anymore because all comms come through the bypass. The building automation talks to the bypass, bypass talks to the drive, bypass and the drive. Same as the old 550. They send data back and forth out to the network. And when they first came out with this, they didn't have that where you couldn't change it. They had to make a couple firmware revisions because people were making a mess. We're not doing PIDs. Let's see. Diagnostics, if you have a fault, or if you want to look at how the drive is actually doing, you can come into here. If there's an active fault or an active warning, these grayed out will be bold. You'll be able to access them. You have a fault and event log. You can look at your faults. And you had a motor overload on 9/10/19. And you can go in and look at the details of the fault. She was running 72.5 hertz. 633 volts on DC, but when you see volts in the drive, it'll usually refer to the DC bus, especially if you see it over 460, you know it's talking DC bus. And 10.9 amps. Okay. Back up. And if you want to look at events, it tells you every time you put it in off mode. You know, if I put it in off mode, it's going to tell you that we did the off mode. Then back into auto. And then, let's see here. Safety interlocks were open sometime or another. I'm not sure what they're tied to. I know there's a disconnect switch out there. Sir? Fire alarm. Could be fire alarm. It could be dampers. It could be the disconnect switch. Could be several things. If you see a safety interlock, that's the one call I get, phone call I get all the time. I got an interlock. I said, yeah, that's something in your in your safety circuits, keeping the drive from running. I can't really tell you what it is because I didn't design that part of the circuit, but I can tell you where to go look. It's terminals 2 and 7 on the bypass. 1 or 2 and 7, because 1 and 2 on the bypass are 24 volt supply. And then we'll back out of there. You can actually look at drive actual values. Of course, the drive's not running. You got 674 volts on a DC bus, which that's normal for a DC bus. Looks good. Let's see here. System info tells you the type of drive you have and what firmware version of the software you have in it. That's pretty straightforward. We do a backup every time I do a startup. Last thing I do before I walk off and leave, make sure everything's working the way either you guys tell me or the contractor tells me. And then I do a backup to the keypad. If the drive were to die, we could replace the drive module, download the software, be back up and running in a few minutes. Pretty simple. Then you have your parameter list, which the complete list is group 01 through group 99. And that's a whole nother level of training. But you can get motor data, you can get a lot of the same things you can get out of primary settings there. Back to primary settings. We mentioned the code, okay. Because this drive is using the bypass, we're not using hardwired I/O in the drive. The only thing that's pre-configured is constant speeds, which is DI3, and you're not using those, so there's no wires on those. It uses the COM setting to get it out of the bypass. The bypass, it tells you bypass is in off. What that means, the drive is starting, stopping through the building automation system. It's following the speed signal coming from building automation system. If I were to put it in hand right now, if I were to hit bypass right here, it would switch over. And if the building automation system was sending me a start signal, the bypass would not run until I put it in auto. So that auto, off and auto here is just the bypass alone. And that's the same thing with the old 550. So if I put it in auto and as soon as I hit bypass, it's gonna take off and run in bypass. So be careful with that if you have a fault on the drive, especially if it's an overcurrent or an earth fault or something like that. Do your due diligence and troubleshooting to make sure you don't have a motor bad, a wire grounded, or something short-circuited, because you can weld contacts real quick if you start it or put it in bypass and it's in auto mode. So be careful with that.
Put it in bypass, does it instantly go to 60 hertz?
Yes, bypass is exactly what it says. There is no speed control on bypass. So when you put it in the bypass, make sure your dampers are where they need to be. Make sure
they change that.
Make sure you can order one with a soft starter, but you can't control the speed. It's still going to go to 60 hertz. If you were to power this up and you were to see phase sequence error on this bypass, that would tell you that the drive is going to spin the motor one way and the bypass is going to spin it another way. The drive is not phase sensitive. It doesn't care how you pipe the phases into the drive. It turns AC to DC and then it simulates an AC signal to make the drive run, motor run. The bypass, it's a cross the line motor starter. It is phase sensitive. Yep. And yeah, we did that when we did the startup. We verified all that during startup.
Well, all of the other ones are set up.
But if you shut it down for 30 seconds, this drive is probably going to go all the way off, especially if it's under a load. They'll do a ride through for, depending on the size of the drive and the size of the capacitors in the drive and the amount of load on it, it'll take the regen of the motor and it will try to keep the DC bus alive as long as possible. But you can't get so much blood out of the turnip before it dies. I mean, I've had them go through, 7-10 seconds, but 30 seconds is a stretch. These are smaller drives. Bigger drives, 100 horsepower maybe, but it also depends how fast and how hard it was running. Because it takes 100 horsepower quite a while for the capacitors to bleed down. In your bypass, since everything is controlled through here, you've got Group 01 is actual data, and you can look at your motor, you can look at input voltage, and what I like to look at is digital input status. And you can look at your 001, that's telling me that the first one is your start stop, the third one is your interlock. It tells me your interlock's good, but it doesn't have a start signal. So if you have a start interlock, alarm, failure, fault, whatever, you can come over here and look. If that's high, then I've had people go after I leave and I don't know how they do it. They change the programming. They set up interlocks in the drive and then it won't run. Then we have to figure it out. But this here, if it's set up appropriately, first one, that tells you all your status of your digital inputs. So that's a quick, easy place. Okay, I know it's not running because I don't have a start signal. Or it's not running because I don't have an interlock. Some people use permissives. That's the thing I don't like about a permissive is on the old 550, if it had a run permissive, it wouldn't tell you. You just sit there and look at it, why isn't this thing running? Well, the run permissive wasn't made. The 580 will tell you if it's got a run permissive over here. You can look at your relay status. You can actually look at all three of your voltages, A to B, B to C, C to A. You can tell what kind of voltage you're getting into the panel. And that should be the same power applied to the drive. That's pretty neat things that you can look at. And those are good places to start troubleshooting from. That is my number. Hoffman & Hoffman pays me to help do troubleshooting and tech support. I've answered thousands of calls, many hospitals around, and I've answered calls from here. So anytime you have a question on an ABB drive, I'll be more than glad to help.